Alright, so in this video I'm gonna be explaining another important paper with the title Global Local Graph Neural Networks for Node Classification. This paper in 2024 in the Journal of Pattern Recognition Letters. The task of graph node classification is often approached by utilizing a local graph neural network that learns only local information from the node input features and their adjacency. So they propose to improve the performance of node classification by utilizing both global and local information, specifically by learning label and node features. So for each label, we maximize the similarity between its feature and node features that belong to the label, while maximizing the distance between nodes that do not belong to the considered label. The use of global information is very important. But recent works propose to harness label information to improve performance of GNNs and propose novel GNN architectures. For example, in this reference, the concept of label propagation suggests that propagating label information according to graph connectivity is useful for node classification tasks. So we have adjacency matrix A, and we consider node classification task with k labels. So we have n nodes and k labels, that's why it's Rn times k. We have k labels. So we have a softmax classification. And for our backbone, we can use either graph convolutional network, graph attention network, or graph GCNII. The feature propagation in this model is this. Now alpha is a hybrid parameter, and this f sub 0 are the features of the first embedding layer. And now we can update it like this. So in general, local information is obtained by learning node features using some backbone. So we use 3 different backbones to demonstrate the benefit of incorporating global information. And then global label features. Our global information mechanism learns label features. The goal is to learn label features that characterize different classes in the data, and will be used in conjunction with the learned node features to obtain classification prediction maps. So we obtain the global features. We consider concatenation of initial node embedding and the last GNN layer node features. We then perform a single convolution and followed by this ReLU. And then because we need a global, so we have, for example, we can use global max pool readout. And then using this global max pool readout S, we utilize k multi-layer perceptrons. So this G represents that global representation. Now once you have that, you can do node classification using this global label feature G. Because the matrix vector product of the final GNN output F with each of the label feature G, and we obtain node label corresponding vector. Now by concatenating k correspondence vectors and applying the softmax, we obtain node classification map. And then we have this training loss that CE is just the cross entropy loss between ground truths and predicted node labels. And this gamma is a hyperparameter. So the second loss is GL, which is global local loss that considers relationship between the label and node features by demanding the similarity of nodes that belong to respective label while requiring the dissimilarity of node features that do not belong to that label and its features. This is a common approach when utilizing contrastive losses. So this is the architecture. We learn node and label features, fuse them to obtain a response per node for each label. And this is just a feature-wise concatenation. But these dots are matrix vector dot product. And here after max bool, we give it to different MLPs to have different representations. So they consider Quora, CiteSeer, PubMed dataset. And this is a nice TSNE visualization of the learned label and node features of Quora.